Hello, in this demo I will show you how you can build event-driven containerized application using OpenShift and OpenShift based components. So first let me introduce you to our stars of today demo. So as I mentioned, OpenShift is the runtime for the application and all the other components. I'm using here specifically code-ready containers, which is lightweight version of OpenShift that you can deploy locally on your workstation as a single virtual machine. Then I will use also the AMQ streams operator, which provides me the Kafka clusters capabilities for OpenShift, and the OpenShift serverless components, which provides me both the Knative serving and Knative eventing capabilities for building the dynamic serverless services that will process the data dynamically. And last but not least, I have developed a service using the Quarkus framework. So I created a micro profile REST service that I have built using the Quarkus, so that I have a very fast starting and lightweight in terms of memory consumption a service that will be managed by the Knative serving. So there are many interesting use cases around where you can leverage this architecture. So just wanted quickly to show you two examples. So first of them is the machine learning based solution where you can build a system to process pictures, in this example X-ray pictures of to detect some disease. The other example from financial services, the solution for asynchronous processing of payment and sending the payments transactions between different banks. All right, so let's get started. So the first step to implement the demo is to install the operators that are needed to provide the functionality I'm looking for. So as you can see here, I have already installed 3 operators. So AMQ streams, which provides for me Kafka, serverless, which provides me Knative serving and eventing, and the Knative Apache Kafka operator, which provides me the Knative eventing components based on the Kafka. The installation of operators is very straightforward. So if you can simply go to Operator Hub, search for the operator we are looking for. So in our case, this is the AMQ streams, for example. You find it, you click on it. I have it already installed, so I don't have the option to install it again, but on the new environment you will have a button here. You click install, and then it will install for you the application. So this is the first step, which allows us to move forward and start installing the components that are needed. For that, I will switch to the command line. I have created number of YAML file with the configurations I will use to install those components. So the first one is the Knative eventing infrastructure. So this is a very straightforward configuration. So we create just a namespace Knative eventing, and then we also create a CRD with the type of Knative eventing, and all the infrastructure will be installed automatically by the OpenShift Serverless operator. The second step is to install the Knative eventing functionality for Kafka. So again, we need to create a file, and again we can have a look what's inside. So here the one configuration which needs to be done specific to your environment is to specify the URL of the Kafka Bootstrap service, which is created in the namespace where your Kafka cluster is installed. So later on you will see I will create a namespace and will deploy the Kafka cluster, and this service will be created for me automatically. And the first step here is to create a Knative serving functionality. So again, very straightforward, just a namespace, and again the CRD with the type of Knative serving, and again the rest is done automatically by the operator. Right, so now we can see that the operator has created the Knative eventing and Knative serving components. So our Knative functionality infrastructure is ready. One comment here, you need to remember that those steps needs to be executed by cluster admin user. So you need to remember to be logged in as a cluster admin to perform these actions. Okay, so now we are ready to log in as a developer and to create a project where we'll deploy our application. So the first step here is to check whether the operator lifecycle manager has installed the operators in our project. So we need to wait for a while. Okay, so the operators are registered in our project, so we can start using them, and the first step will be to create a Kafka cluster. So again, I have created a file. So the configuration is very straightforward. So I'm creating 3-node cluster of Kafka, and there will be also a 3-node cluster of zookeepers with the ephemeral storage for our demo, and I don't specify any resource limits, hardware resource limits for our pods, which probably you would do on your production environments. So let's see how it goes, the creation of the pods. So you can see that the cluster is almost up and running, so we need to wait for okay, so our Kafka cluster is up and running now, so we can create a topic. So another configuration file I have created. So we create a topic. So the content, again, very basic: topic name, number of replicas, and the number of partitions. And also I will create here a Kafka bridge, which I will use to send events data into the Kafka cluster. So this will create another pod, but this should be also very fast. Also, it creates a service which we need to expose to allow access to our okay, so here we go, and we have a route that we can leverage. So now we can take a quick we can give a try and see if our Kafka cluster is up and running. So we can send a couple of messages, and we can see they are saved. So our Kafka cluster is up and running. So now it's time to create our Knative service. So I have created another file here, and let me show it to you. So very basic configuration. We need to specify what container should be executed when the service will receive some traffic. I have specified some limits for resources. You can see only 50 megabytes. Thanks to the Quarkus framework, I can run Java REST service with just 50 megabytes memory. And I have also created an annotation for Knative serving autoscaler, where I'm basically saying that I want I want single instance of my container to process just one request in parallel, so that you can better see how this scaling is running. So now we can switch for a second to web console to see how this serverless configuration is looking like. So we have a service created with some endpoint. So we can call it using this URL. So there is a route created for it. We'll have revisions every time you modify the configuration of your service. The new revision will be created, so you will have over time multiple revisions here. And you can create a route where you can also implement a traffic split between different revisions. So that, for example, if you want to test a new version before allowing the full traffic accessing it, you can simply here move a slider to one side or another, and we can quickly see whether our service is running. So let me just click here the URL, the first request, so it will be starting for a while, and here you can see our service in the topology view starts, and it's up and running. Okay, so the last step we need to perform is to create a Knative eventing component which will integrate for us the Kafka topic with our serverless service. So let's see the content of this file. So what you can see here, we need to specify the bootstrap service Kafka service URL, topic name, and the name of the serverless service that will be responsible for processing the data. So this should create for us one more pod. Here you can see it up and running. So now we are ready for a final test. Okay, so I will create a stream of data. I will leverage the Kafka bridge I created and will send a stream using the HTTP bridge. So let's see here. You can see now there are 0 instances of our service running. So now I start our event stream, and you can see immediately pods are running and are starting to process the messages. We can stop the stream now, and you will see that in more or less a minute all the pods will be killed. Okay, so following the default configuration, after more or less a minute, all running pods were scaled down to 0, as you can see. We can now again start our stream, and again you can see the same reaction. The pods are scaled up. So this is how this solution works. This concludes also my demo. Here I just wanted to show you a link to my GitHub where I put all those YAML files that I was using during this demo, so feel free to use them in your own environment for your own testing. Thank you very much for your attention. I hope you enjoyed this demo.